record, share the screen, share the browser screen. And okay, so let's start. Welcome and hello everybody. I think we all know each other by now, so there's no need for further introductions. So my presentation is titled Interfaces through the Ages, and I will kind of share my own experiences with Destio and its various interfaces, the iterations of its interfaces that have come and gone through the ages. So this is the contents. We have a short prologue, then we kind of go through this history that I have divided according to these eras and ages, and we go all the way into the future from the prehistoric times. So as a prologue, I started working in a group in 2019, and since the beginning, I have always been working with Destio. And prior to joining our group, I have had some experiences in developing web-based interfaces. So almost all of the interfaces that Destio has gone through have been web-based. This is why this is relevant. And shortly about my experiences, my first experience with web interfaces was in Italy, in the DAMA project at the Laboratorio Nazionale del Gran Sasso, LNGS, in the summer of 2016. And well, they were doing stupid stuff. They had this experiment where there was this temperature reading. I will show a picture of it shortly. And they were checking it like constantly. Some of the researchers always had a browser tab open with a web camera feed, just looking at the meter and seeing what's the temperature, because it was supposed not to go over certain amount and not go under certain amount. So that was a very stupid thing to do, in my opinion. So I suggested that maybe this can be done in a smart way, and then that became one of my projects. And just to tell you that, so this is underground physics, and it doesn't mean that it's some kind of hipster physics like some very special people do, but no. When we talk about underground physics, it's about being underground because we want to either study something very rare and we don't want interference, or we want to study particles that or certain kind of phenomena that comes from, for example, very far from the outer space and then goes through everything, and then it can be kind of filtered out from the other stuff that is going around by being very deep underground. So about underground physics, I won't lecture you more about it, but just for you to know. And the kind of webcam feed that there was kind of like this. So it was webcam that they had to move and zoom because there was another reading also that they were looking at. So, but this was the more important one. So this is the kind of stuff I work with, this kind of images, which were updated every few seconds or so. And I had no idea about machine learning or anything. How I did this was that I just used image manipulation, OpenCV, and I basically filtered this black area out. I picked up these digits, and then I had this bank of digits, so single digits, which were taken a picture of each digits like many times over the course of the time, and I had this kind of bank of them, and I just matched the figures to each other and see how many pixels matched. And based on how many pixels matched, I were able to deduct which digit it was. So I could talk so much about this project because I don't know how I managed to do it without any kind of knowledge on machine learning or visual, other kind of visual learning stuff. But anyway, I digress from the main point of this point. And the second experience one in Finland, then things were done in a bit more sensible way, because at least this time the sensors we were able to access the sensors remotely. So it was just a question of collecting data and showing that data in some kind of dashboard. So I built this kind of dashboard, and that's it. So this was also underground, 1.4 kilometers underground. And fun fact, there's also a sauna, which is the deepest sauna that exists in the world. So there is no sauna that is deeper than 1.4 kilometers in the world. I didn't use it, but it was there. And this is a 14 experiment from which I collected this data. And this is kind of a sheet that you see. So this kind of sarcophagus, you have these kind of lead blocks, then you have on the inside you have copper blocks. And they are very heavy. If you have ever handled copper or lead, it's surprisingly heavy, but you have kind of this kind of tile of it. But it was shielded from background noise, and then there was a small setup with photomultipliers inside and so forth. But this is not about this experiment, but just to let you know. Anyway, to the main point. So my experience with tested interfaces, and we start from the prehistoric ages. So basically, what was done before I joined the group, and kind of my experiments, this very crude experiments with what was done and trying to extend. So there was WebAV Nimbus in 2016. Was the first time I think I touched it. It was during the non-linear optimization course, which I think was given by Jussi, but I am not sure. At least somebody was given the course. And it was, yeah, it was at the very end of the course that we explored this WebAV Nimbus. And I find it very crude, but very cute, like very cool. I like it. But it's a pain to use in my opinion, because I can never, I wanted to make this problem to show it here, but I can never like come up with a problem that would work with WebAV Nimbus. So maybe it's just my clumsiness, but anyway. And then there is the in Nimbus. Often talk about, never really see. I have seen screenshots of it, but it seems that nobody can get it running. Nobody really knows where the source code is. This might also be wrong, hopefully. But yeah, it's quite elusive, and maybe the lessons learned from at least in Nimbus is that maybe open source is the way to go, so that we can actually return to old projects and learn from them. This is maybe the most typical screenshot that I have seen of in Nimbus. It's not good, and there's a lot of stuff that we could translate to what we have today, but yeah. This is what we have, and then there is WebAV Nimbus, which everybody can use through the web. And I think it was also the first web-based interface ever for interactive multi-objective optimization. So this is
not only interactive multi-objective optimization, but optimization overall.
Yeah.
Because this is so true. The first version is so old, dating back to 1995. Yeah. Some of you were not even born then.
So I was.
Me too.
I would not have guessed. But so yeah, WebAV Nimbus, and it's kind of a giant on whose shoulders we are standing today. So it's an important, not an artifact because it still exists and it can be used, but it's all, it is there, and it is kind of the basis of everything that we have today in a way. And okay, all this the one by mostly done, I think, by Vesa, and I couldn't get it running. So this is kind of what I remember of one of the kind of components that we had. These kind of sliders that you could give values and so forth in a Jupyter notebook. So it was a widget. And this is one of the things that I think was still better in old Destio, that it was very easy to experiment with the visual components because they were in this notebook environment. And I think that is something I'm still working on myself to get our modern components in this kind of same environment, but it's still work in progress. And something I was surprised when I look at this now again was that these were also in TypeScript. So it was, I thought it was in JavaScript. No, it was in TypeScript that these components were implemented. But instead of React, Vue was used and Vega 3, but we are using React and D3. So Vega 3, I think, is based on D3, but it's kind of higher level, if I'm not mistaken. But yeah, in a way, we are not so far away from what were, but still, I think we have done things better in many ways. So I cannot get it running. Use your imagination. If you have seen it, you have seen it. It's a shame. And then there was this my attempt to implement a web page. So it was www.destio, the original name. And only one method was implemented in this kind of new interface. And it was very crude, very raw in a way. It was eNautilus and it was buggy. It was based on the old version of Destio, which was a huge mistake. It did not really work. And though it had, but it looked cool, I think, and I have very bad taste in these kind of things. That's why we have Johanna here. So it looked like something like this. So very 90s. And I can demonstrate it, though it doesn't work. So this cannot go wrong, this presentation. So we can choose the method. We can choose the optimizer for the single objective. So the scalarized version, and then we can choose the problem. We have this custom option. Then we can like have expressions like x1 plus x2. Then we have like from 0 to 5 or 4, whatever. Add more, then we can have like, let's make these conflicting x1 minus. This is not a non-linear problem, but whatever. This probably won't work. I won't even show you the river pollution problem that we have because that doesn't work. Submit. Okay. 0, 3, current value 2, 0, 3, whatever, 20, current value 4. Yeah, so this was cool. I had matchx doesn't work, but this was in LaTeX, so it would show you the problem like this before you start optimizing. Then I guess this is okay. Then eNautilus starts, or Nautilus enhanced, and let's say we want 5 iterations and 3 points per iteration, and now this will break or not. Let's see. Yay, it broke. So it was buggy, didn't really work. That's kind of the.
But good attempt.
It did work at some point, I swear. Please trust me. With the river pollution, I can show you the kind of interface that we had.
I also like the visual design of it.
Yeah, it's perfect. Let's go with 3. So whatever. So let's continue. It doesn't work to work now, but this was expected. So the point here, it was buggy. It worked. Just trust me. But no, it actually didn't work. So it worked that we saw this kind of bar charts with the solutions, but then the solutions were nonsense. And this was because the eNautilus implementation in the old Destio was something that, first of all, I didn't understand at all. And second of all, I think it didn't work. And I talked with this about this with Vesa, the mastermind behind the first version of Destio, and we agreed that there might be these kind of very strange things that. But yeah, it didn't work bottom line. And about the code, like I said, I heard that it was implemented apparently in only like a few hours during some flight, some conference, or a major part of it was done very hastily, in other words. And really, it was a nightmare to figure out how the code works. Like I saw that there was this fantastic idea, like to abstract things and so forth, but it just didn't work. And I thought that I would rather really stick a practice in my brains that start working on its current state on Destio. So I had this kind of idea that I think I will revise this whole thing myself and it will be easier that way. So this brings us to the ancient era, and this is kind of me struggling with new tools here. And this is the kind of narrative I'm trying to convey here. But anyway, so Destio 2 was born, and it kind of contained everything and more that we had in Destio, but it didn't really contain evolutionary methods. That was kind of an overlook. So I did this in my own small bubble. And it was more modular. People could have extended it in practice, and it worked, which was a huge improvement on the old version. The old version, I think Nimbus worked well, but some of the Nautilus methods had something very strange going on. I'm not sure what it was, but I don't know. And yeah, there were many methods implemented. Achievement-scalizing functions were actually modular, so you could implement more and choose what you want to use, and other stuff as well. And it's available if you want to explore my implementation. Just go to GitHub and find Desto V2. And around the same time, I was also tasked to build a website for Desto. And this was in Django. The interface I showed earlier was also in Django, but it didn't really make much use of the many features that it had. So this website that I made, I can say I made it properly. And I had one goal in mind. It was that I don't want to become the guy who updates the website every time somebody has something to add there. So that is one reason why I chose Django, and also that's the main goal I had in mind. And I think I succeeded because many of us have been able to update the web page. It hasn't been always me. And the code for the website is available on GitHub. It's a very good, if you want a homepage, for example, that looks like this homepage, you can use that as a template. That is something I plan to do at some point, but haven't had time yet. That is also available. And like I said, this was kind of the first time I got really into web development, in full stack development with Django, because it's a full stack library or framework. And yeah, it was also the first time I published something on the World Wide Web as in a web page, and it was a horrible experience. But I learned a lot. I don't want to repeat it. I don't have to, because like I said, I learned a lot. But there were many things, and maybe the lesson learned here was that if I had invested like 1 hour to read through the documentation instead of Googling ready answers from other users, I would probably have, say, 20 hours or so. So laziness in not reading documentation is maybe the biggest thing I have committed in all of my journeys. But yeah, let's not discuss more about that. Solutions found on the internet, but at least the main documentation is usually the best source for information. So medieval ages, and this is kind of where stuff got refined, I would say. So not really. Maybe medieval ages would tell that everything was stalled, but not really things progressed. So this is maybe not the best age and to describe this era, but yeah, it was time to really consider how we built these interfaces. And Plotly seemed very promising because it had a lot of ready-made stuff, and it was marketed as this kind of interactive data visualization. But it was quite fast, or quite quickly, I found out that interactive meant something else in Plotly than what it means for us in multi-objective optimization. But anyway, Plotly was used, and it was used to build the best interface to ever exist, at least according to Kaisa. Because I built the interface for eNautilus. Actually, this is false, because I had the previous version for eNautilus that I just showed you, but it didn't work. So let's say this is the best interface ever to work for eNautilus. And I remember Kaisa saying that this is the best interface, but then she also made for eNautilus. But then she also made the remark that it might also be the interface to exist ever, but small remarks like that we can ignore. And it was also the first time that I had implemented a method that is available on the World Wide Web. So even though the first method I showed was a web browser-based method, this is the first one that anyone can access. And most of you have probably seen this, but we have two interfaces for Nautilus Navigator and eNautilus, and this still works, no problems. You can give it some dummy data like this. You can upload the data, and then we start optimizing that. One issue here is that this is not really like, yeah, we can zoom here, this is very cool, nice, but we can't really, how to say, we cannot click these things and select things from here. you can brush these axes and so forth. But selection and things like that are not very interactive. You have to use these kind of radio buttons. You cannot click on the tables. So this is not very interactive as far as it goes for multi-thread optimization. And then there is also the interface for Navigator, which I implemented. Also made this fancy logo because I was practicing making vector graphics at the same time. And it is like this, that you can set the levels. You cannot set the bounds, but you can set the aspiration levels using these sliders. And then you press start and stuff starts working. The issue here is that it would be very nice to set these levels by dragging these black bars, but it's not really possible in Plotly. It could be, but it would require so much work that it's better to just do our own stuff, I guess. But anyway, that's kind of how the interface looked at the time. And that, like I said, anybody can play around with that if they so wish. Then there's this Nimbus interface also made in the same environment, but it was never published online, and it was kind of not very usable, not very nice. So I think Ade has seen it. You have seen this version, but not many others. It can be used, but it's not maybe the best one. So maybe the main lesson learned is that Plotly is not the right tool to do this stuff. So what follows medieval ages is Renaissance, and this is the second Renaissance because, as you know, Renaissance means like rebirth, rinascita. So this is the second Renaissance because this is kind of led at these times. We also got the third version of Destia, and then we kind of used Flask, the web API, to connect Destia with this kind of web word, JavaScript word. So that's kind of the narrative here. And so Destia 3, so these are in quotes because we really don't have these versions of Destia, but it's just to differentiate what we are talking about, the different iterations. And it was like, Destia 2 was nice, but adding evolutionary methods there didn't really, it could have required a lot of work because during all of this time, Bookinger was working on evolutionary methods, which were then later included in the final version of Destia into their own package and modules. But at least at this point, it was pretty clear what kind of package and modules we need in Destia, and so we implemented them, and then we have the Destia that we have today. And it's much better. It has a very clear modular structure. Things are quite simple, at least in my opinion, when compared to the other revisions that we had. And many people have come and contributed to this version of Destia, which is very nice. It means that it's usable by others as well. So I think that's kind of the most amazing thing about this version that we have now. And also the fact that if something big breaks or we have this some new critical need that we need to implement, it will probably mean that we don't have to implement the whole thing, but we can just add it there, hopefully. But we'll see. And kind of the structure that we now have is that we have a framework, we have the packages in the middle, and then we have the modules. And these are kind of the core modules and packages that we have right now. Hopefully, we have this kind of article booking from this version of Destia. Hopefully, it gets published or at least accepted first soonish, but we'll see. And yeah, so the fact that why we used Plotly or why it was chosen, it was because it was easy to be used from inside Python, because Destia is implemented in Python. So everything that can be done from inside Python is easier. But it was clear that Python does not offer the right tools to do the job. So that is why we had to look outside And since we want to do web-based stuff, it is very natural that we move into the JavaScript world, or actually TypeScript world. And this then led to this kind of new web interfaces, of which I gave a tutorial talk a week or so ago. And we ended up using TypeScript and React. Also D3 for implementing the new visual components that we have. But then there's the issue that how can we connect Destio, which is in Python, to these interfaces which are in JavaScript and TypeScript. And the answer to that, as you see in the figure, was to implement web interface which can handle HTTP calls. And the nice thing about this is that it's not just limited to web interfaces. Any interface that can handle HTTP calls can be used in practice and in theory and in every other kind of way with Destio, and different tools can be used to implement interfaces if somebody wants. But of course, it meant more work. And then also the point that I made about the new visualizations, because these kind of interactive visualizations that we need don't really exist, so we have to implement them ourselves. There are some, but they are kind of scattered. So having some kind of library collecting them into one would be very nice. And after searching for tools, we had also Mika at the time working on this. He used victory.js, which is based on V3, but because it's a higher level library, it means that it's limited, more limited than something lower level. And it didn't really meet the needs that we had. It had nice features, but not nice enough for us. So in the end, we ended up building these new components with V3. So far, I and Juuso have been building these. And yeah, so then modern times. So what has this all led to today? At the moment, we have a truly open source and modular Destio framework. This is nice. And we have a web stack. So we have Destio, we have a web API, and then we have a front end. So we have a full web stack, which enables the development of new graphical stuff for Destio. And we have these new interactive components, as said, and contributions to Destio and its other parts have been made from outside people. Not well, outside people, I mean, new people have come and made contributions to Destio apart from me and Hubinder. And for more information on the web stack, there is a YouTube tutorial, which is a recording of the technical talk I gave last week. So in other words, we have come a very long way, in my opinion, from 2019. And this is kind of the web stack. This might be familiar for some of you. So we have Destio, there is the interface, then we have front end, and then we have a user. Part of the front end is the Destio components library. This is what is meant by the full stack or the web stack. Then we have the future. What does the future bring? Where do we go from here? And we are a lot more, a lot less restricted than what we were in, say, 2019. And we have really only begun exploring these different options. And like I have already stressed, that we have very much evidence that students can come and make contributions. This is very important, and we should keep this in mind. And significantly, I think I need significantly, but you get the point. So it's not just that they come and maybe change some typo in the documentation. No, they make actual contributions. And that is very nice. We should have more trust in the students and realize that they are an asset that can be very valuable for us. And now it's time for some neck exercise, so you can turn your neck on the left to see this figure. But the point here is that when Stefan came, he was able to prove that really we have just tapped into the potential that graph can do, and we implemented these physical interfaces that can be used to control the methods that we have in the SQL. And this is very nice. And this is not a very trivial interface either because it's modular. There's also, if you go to the link that goes to my talk about the web stack, the tutorial I gave a week or so ago, on the channel, there's also a video about Stefan's talk if you are interested. And also on user's talk, where he tells you how he also works on the interfaces and the components. So there is more stuff related to that there. And but like what could happen is still out there, and maybe in 10 years or so, the quartal of the academic world is said to be 25 years. So who knows, maybe we will have some kind of chips that will allow us to make real-time multi-chip optimization related decisions in real world, real-time, real scenarios. Who knows, but hopefully you won't have to watch a cactus in your brain.
This is a kind of in a way, interesting but scary thought.
Yeah.
Because when we had this quite some time ago, the director of our brain research center giving the talk, she said that with the current knowledge of the knowledge of those days about human brain, she said that by touching a specific part of the brain, we can influence the decisions that humans make. So if we start going that way, then we can manipulate decision makers in any way we wish them to behave, which is a little bit scary thought.
Indeed. But
maybe something in between.
Yeah, maybe something
like a cactus in between your brain lobes.
And of course, the mind does not exist in the brain, and decisions occur in the mind, so it's a little bit more complex than that.
Yeah.
So I wouldn't be so afraid.
And if we look into and you are not the thinker of your thoughts.
No.
Yes. Anyway, let's not get too philosophical here, but yeah, that's it. Thank you, and really thank you for listening. And I think I managed to keep this short enough for today because we are all, of course, very, very excited to be here physically, and we can take only so much. So let's keep it at this for now.
I have one little criticism, if I may. Could you go back to the slide 19?
Is your criticism that I don't have? No, I have slide numbers. Oh, this is too heavy.
What about the recording?
It's fine. We can cut the video. The criticism is too rude. Yeah, let me refresh this. So what was it, Tuomo?
19.
15, 19. This one? Okay, please.
Yeah, that's the objective which you choose. I find it a bad one for job security.
Yeah, but you know, the kind of bugs that we had in the old test, the features, were, according to Vesa's own words, kind of his way to secure his job. So that led to a lot of pain. But yeah, I agree what you are saying, but I am not afraid that my job would not be secured, at least for a while, hopefully. Kaisa is not looking at me, so maybe she is avoiding eye contact. But that is very true what you said. So, any other questions?
Not a question, but I think you would we would need to give you an extra applaud for the excellent narrative and the magnificent visualization.
Well, Thank you.
Wonderful.
It really makes my day.
So there were so many levels. in
Yeah.
this talk.
Yes,
Like, yeah.
indeed, really nice.
We have made an interface to our brain with this.
Yeah.
Yes, pieces of art.
Small cactuses. But for example, this, I'm so proud of this.
Yeah, it's
It has like
excellent.
stupid jokes.
Yeah.
But the narrative is very clear. Like they're connecting Flask is a web-based in the web framework, including the web API for SEO. It's kind of like connecting these two worlds, like the kind of earth to the sky. So I think I improved on the original work a lot.
Yeah, and then that's their head, the D will go really nicely to the head.
The brain of the old.
Yeah.
Yeah.
Any other questions or comments? Yeah.
So, Giovanni, I have a
Please.
question. So, do we already have this eNautilus in D3, or is it only in the Plotly that we have?
In Plotly only, so eNautilus will be coming eventually. It shouldn't take too
Okay.
much to implement actually, but because we have the
Okay.
visual components. Yeah.
Because some of the researchers here ask for it, Nautilus actually. They wanted to use it for their lectures and let their students use it. So,
You can use the Plotly version because it should work,
oh, okay, they can use that. Okay.
at least in others, because others used it in her case study and nothing too
Okay.
strange, at least.
Okay.
Any further thoughts, comments, or questions?
I have a question.
Please.
Are you familiar with Shiny?
Shiny, I have heard about it. Yes,
But you don't.
haven't used it.
Okay, so you don't have any opinion. Is it going to be dinosaurs also soon, or is it worth of working and practicing to use it?
So one of the big lessons that I actually didn't mention here is that when using different tools, and now that I have also used different languages, I have realized that it's not really knowing a language or a library. It's about knowing these kind of design patterns that exist. Because Plotly is very similar, for example, to React. The kind of the JSX extension, so that you can write actually HTML in the source code in TypeScript and JavaScript, is very similar to what is done in Python, where you can write HTML code in Python so that you are able to use all the kind of variables and other stuff you have in Python. And this is a design pattern that has been repeated many times. And Plotly has also been said to be the React of Python, but actually there is another new recent library that implements the whole idea of React in Python, so that you have this kind of same kind of hooks and follow this kind of reactive design pattern that we have in React, also in Python. So I don't know, like learning, for example, Shiny, I'm not sure what kind of design it follows, but just learning it and using it is itself a valuable experience. So I don't know what it will become of it, if it's ever to grow much, but I think it's still worth looking at, because I think that the design pattern, so I'm not very familiar with it, but I guess that it follows some quite modern design pattern that is itself valuable to learn.
It's an R, right?
Yeah.
Yes.
And it is very similar to Plotly, like Plotly has those layouts, and then
Yeah,
you have those decorators for functions. Shiny works pretty much the same way.
I think there is JavaScript. It's built on the
Yeah, it's
JavaScript.
yeah, that is very often the case, that everything is actually built on JavaScript when it runs in your browser. So, any other questions, comments,
And second
criticism?
question, what
Yes.
is the place where are all those these presentations and videos available?
So on our YouTube channel are some presentations have been recorded and are there. If you actually, it's very easy to find, because the word Destio. Will I show? Okay, I'm locked out. That's good. So if you just set Destio on YouTube, you should find My talk. And then, so it's the MOP group. So I didn't remember that name. But here are the talks. This is the my seminar. Not the seminar, sorry, the tutorial I gave. Here is users talk. And then we have,
That was my,
was there Stefan's talk? Was
It is there. Go to the video stuff.
Oh yeah, this is this one. Stupid. Yeah, so there is more. Oh, or is it not? Is it unlisted?
I think it was not recorded.
It was not recorded. Oh no. That's a shame.
I think it
was.
It could be unlisted though.
What the
Go to
APC
Dustin's website because we must have published the news.
Yeah. So there's
But anyway, this question is a very valid one, so definitely we should have these links at the DESDE website.
yeah, we have them there.
So that would be the
it is
place to
unlisted
go
website.
and have the collection.
You should unlist it.
Yep.
Yeah, so it is available. It was just not public,
Mhm.
but it can be public. Stefan agreed that it can be.
How about these presentation slides? Are they?
They should be. I can add them to the demo wiki. So
Yeah, the demo wiki site is the place where we have agreed to collect the slides. So we don't put in different places, so they are all there. And you should have access to the demo wiki, right?
Yes.
yeah, is it by the way public, the demo wiki?
I don't think so.
Okay, so you have to
It's
log in.
Demo for demo people, because we also have their slides of some visitors who were not comfortable in making their slides openly available, but only to demo people. So that's why this is the way. So if we want to make slides publicly available, we need to put them somewhere else.
Yeah, for example, the slides for my tutorial are available on the demo. I can also add these, not that. I think the value is more in the presentation.
Yeah, but-
today, but I can add them, of course,
No,
of course.
no harm done if you put them there, so
Yeah.
we can admire the connections and so also later.
But this is kind of can still relate to this kind of state of mind that I'm just doing stuff and put stuff together and something comes out, hopefully.
Yeah.
Okay.
That's a way of brainstorming.
maybe you can utilize some of the visuals in your lecture.
Yeah,
When
like
the time comes.
Yes.
Mm.
I will have like brainstorms there and stuff like that. Because I still haven't made the figure of like a storm with brains. But it will come.
Well, there's some time till.
I really like this kind of stock images and stuff. They are quite personal. Okay,
Any further questions or thoughts?
anything is welcome.
So like now the program control is in Python, like initially I think Bhupinder was doing everything in Python, you run the Python code and it starts the server. And is it still like that now or?
Yeah, so what we basically have, if you talk about what we have today, is that we have there's the web API, which is just a Python server, which exposes Python, desktop. And then we have the web interface itself. So this is just a web server that serves the page. And I actually didn't show this during the presentation, but most of you have seen this. So then we have, this is the kind of end result for now. And
We might be beautifying it
yeah, hopefully.
later a bit.
But then you can like define problems and define methods or set up methods. So the wordings are very bad here. But okay. Let's go. I always show my own methods. We have navigator now. So this is kind of the new version of the navigator. Like I said, things can be set by tracking stuff which is hard with this kind of laptop interface, but stuff can be tracked and it can be set if one wants, even numerically, and stuff is updated. So these are always linked. Yeah, that's how it works. We have the web server which implements the web API, and we just need to load a web page. Because this is a single, if you look at my tutorial, this is a single page application. So when you load this page, you basically load an application. You don't always get a new website, a new page from the server, like it traditionally has been done, but you just get one application which then has all its contents there, and it then gets all the data it needs from the server just by making HTTP calls. So you just get the contents, the data that you need, not the whole page.
Similar to this Ajax or.
Yeah. These are the same word, same.
But like if I have a new email algorithm or something, how much changes I need to make to it?
Not necessarily to the method itself in Desktop or wherever it's implemented, but
That's good. So
yeah. So the point is that you just need like it's that easy to do. But what you need to do is to implement web interface for web API here. So you need to make it usable through here, and if you want to look at some example, you can go to resources, and then there is method resources, and you can look how it has been done for RVEA and Nimbus and Nautilus Navigator and the reference point method. So, and if you have questions, ask me, but I would start with looking at the tutorial talk I gave if you didn't follow it. I think you didn't because you had your thesis to work on. Yeah, so that's quite understandable.
I'm currently in the process of simplifying that particular file that you showed somewhat for email method at least.
Yeah.
So it won't be very complicated to add an interface for any method that you do.
And we have quite many tests there, so refactoring stuff should be quite safe. And one thing I wanted to say about Destio 2, it was full of tests. So it was tested very well, but our latest version of Destio doesn't have so many tests. So that is something that we can improve, at least from now on when we implement.
Should.
Can and should. But yeah, at least from now on, always when you implement something, write at least some sort of tests, just to check that it works logically, if not, nothing else. So that was maybe the best thing in the second version of this, which I wrote. And I can tell you that it was the best way to get into interactive methods by implementing that kind of stuff, at least for MCD and standardization based methods. Okay. Yes, please. Thank you.
So we are planning to switch between methods during the solution process. What do you see these technologies we are using now can serve the purpose that switching between UIs or the methods is possible, or do you think that we can make it, or we shall change something?
I think that things are so open right now that it's just a question of implementing it. And I don't think we have to make any kind of drastic changes because most of it will be in the interface. Because like changing methods is possible. It's just when you want to change method, you change method. It's just the interface, how the user can do it and how it kind of shows to the user, things like that. Those are the kind of challenges in my opinion right now. But like I said, we are so less restricted than what we would have been in 2019. I'm so glad I came.
Me too.
But it's not perfect in any mean, and I'm not bashing on Vesa's code because, like I said, the idea was there. I saw what he meant to do, but it was done in such a rush, I think, or he was so fed up with it or something that it didn't lead to what he maybe had visualized in the beginning.
Yeah, and sometimes well, sometimes you need to implement things in one way before you have a clear idea how it should be done. So
Yeah.
sometimes it just takes these iterations, and you can't cut corners short. It's easy to look backwards and say that, oh, I should have thought of this and I should have done this that way. But when you start from scratch, because when we started designing this, there was absolutely nothing. There was absolutely nothing. So everything had to be kind of thought through and invented. So that's why it takes some iterations to mature with the idea. So everything has kind of played some role in this, as you showed. There is this kind of a path that has led to where we are here. And I just want to give credit to Vesa in this, that when he started, he had a blank space. He had a lot of experiences, what we had done with Nimbus. So many things from there as a kind of a experiences to utilize. But in this kind of a setting, it was just starting on an empty desert.
Yeah, so he basically had to dig up the clay.
Yeah.
We already had the clay, we just had to modify it a bit.
Nice metaphors we have.
Yeah, but like I said, there are these giants always on whose shoulders we are standing, and then they start making this kind of pyramid that there's giant over giant over giant. But very good. Like I said, I'm not bashing anybody here. That's not what I meant to say, but and also the kind of mentality that I have said it many times, that I'm not married to any of my work. I'm always ready to do it over if there is good reason for it. Because otherwise there is this kind of diminishing returns when you start to work on broken stuff and try always to improve it, then you start to kind of like stalling at some point. But we'll see. It will be very interesting to see where we are, say, in 2-3 years with all of this.
We keep learning all the time.
Yeah. And I want still to advertise that if you have some topics related to Desti or any of this, which you would like to see more material on, or don't quite understand, you can just suggest the topic, and I can think about if I can make a tutorial about it, something recorded, so that others can also benefit from it in the future. So not just who is asking, but also other people. So we started having this bank of material that we can then hand on to the unfortunate souls that come here, and they can start learning. And sorry, for fortunate souls, of course. But, okay, please.
One more about the giants. Like you said that now we are standing on Vesa's shoulders.
In a way, yes.
Vesa is the giant and this work. But is there some other work that you have been taking some that from other universities? Also, have there been any similar project in other universities or in some companies, technology companies, or it's everything built in this within this group?
What we have built has been in our group. So to be honest, this is also one of the cons. I would say that I haven't really looked elsewhere much, more than just libraries that exist. I have tried to search for stuff, but just have not found. So I would say I haven't taken much inspiration from elsewhere. But for example, Puja mentioned that in the research group that he's visiting, they have stuff that is, quote, light years ahead of us, right?
Puja, are you?
Yes, I'm here. I'm here. The video was frozen.
Sorry.
So can you repeat what happened?
So visualizations wise, you said that the research group you are visiting right now has stuff that is light years ahead of us in terms of visualizations.
Yeah, they're like, basically we don't have much in D3 right now in the D3 library, but the stuff that they have are all kinds of linked plots. They have like dimension reduction plots for seeing the cluster of, like, to identify different clusters of solutions. They have some kind of sensitivity analysis about decision variables, like they can visualize it kind of, and like different type of filtering in the objective space or decision space. Like their software is pretty advanced about visualization. Yeah.
Yeah, like stuff like that. It would be interesting to see and see what we can do with it. But
yeah, I'm waiting for them to give me the, like, right now it's kind of in a local server. They are going to upload it into a public server so everyone can use it soon. I'm waiting for that to happen, and then I'm going to organize this meeting between the two group of us, and then like probably we have to explain Nautilus again to them, and then they explain their software to us.
Okay, that's nice. And also similar stuff has been worked on by the people in Manchester. I don't remember their names. No, Manuel and Maura. Yeah, they seem to have the same kind of needs that we do, and they seem to have pursued a similar path in these web-based interfaces. So I think some kind of collaboration or with them would lead also to good things.
Yeah, next week probably. I have a meeting with them today again. I'll ask it at what the stage is it. Like, we can have it even sooner if you don't want to use it and you just want to see what kind of stuff they have.
I don't think there's any hurry, so.
Okay then, all right.
Good to know that something like that is coming.
Okay.
Okay. Shall we thank Giovanni once again?
Thank you.
Thank you. So we have then some other topics to discuss. The accelerator